I'm going to go through two very different methods of solving this question. So method number one is I'm going to say that x is this 5-digit number PQRST. I'm not multiplying them, it's my 5-digit number, which means the original number is 200,000, because this 2 is in the 100,000s column, plus x. And if I multiply that by 3, then I get this 6-digit number, which is 10 times more than the original PQRST, so 10x, and then I'm adding 2 to it. So I've created an equation for x, which is PQRST. And we can solve this, so I'm going to multiply out the bracket. Which means that 7x is going to be 599,998, and we can therefore work out what x is. So let's just work our way through. 7's into 59, go 8's remainder 3. Then we get 5, remainder 4, 7, 1, 4. So that is my PQRST. So the original number was actually 2, 8, 5, 7, 1, 4. So I want to add the sum of the digits of these. I'm going to get 10, 22, 23, 27. Method 2, we've got our 6-digit number, 2PQRST, and I'm going to write that down. And I'm going to write it as a column multiplication. So then it gives PQRST2. And then we're going to just slowly calculate what each of these letters must represent. So we're doing 3 times something to give 2. And let's think about it. 2 wouldn't work. That would give 6. 3, 4 would work. Would anything else work? 5, 6, 7, 8, 9? No. It has to be 4. So t is equal to 4. And I could cross it out, or actually I'm going to just write down that t is 4 and then write the calculation down again. Okay. So when we do this, we're going to do 4 times 3, which is 12. So we're going to carry the 1. And then we're going to do 3 times s, which is going to give me something that ends in a 4. But that's after I've added the 1. So s equals 1 would work, because then I'll do 3 times 1, which is 3, and add the 1 to give 4. Now, would anything else work? I need it to end in a 3. And it wouldn't, because 3 times. I mean, it might be worth writing down the 3 times table at this point, but we're going to get, we're going to get 3, 6, 9, 12, 15, 18, 21, 24, 27. So it must be that s is equal to 1. Okay, let's keep going. So this is definitely taking longer than the first method, but it's still pretty solid, I reckon. Okay, so 3 times 4 gave us 12. We've got the 4 there. Right, now 3 times r gives us something that ends in a 1. Now this really helps. So we can see that r is going to have to equal 7. So we've got to carry the 1, we've got the 4, we've got 3 times 7 gives 21. So we're going to have to carry a 2 here. So 3 times q gives us something that ends in a 7, but that's after we added a 2 on. So we need it to end in a 5, in fact. So q must equal 5. Again, we've just got one more to find. So I've got 15, add the 2, 17, so here's a 1. So now it's 3 times p ends in a 5, but that's after we've ended a 1, so actually we want one that ends in a 4. 8. Okay, so p is equal to 8, which gives us our original number as 28714. Actually, it gives the final number as 857142. Has the same digits, but either way, this is the one we're focusing on. We sum these and we're going to get the 27. So 2 approaches. It's got to be said, this first way is much quicker, but the second way, is useful as well.